Hi, we're going to be talking about and showing you impulse versus momentum. These two concepts will be shown throughout our various experiments, proving how impulse and momentum, while different, ultimately are very similar.
Momentum is mass in motion, while impulse is the change in momentum. Without one, you simply can't have the other. We hope you enjoy our video and gain knowledge on these two important concepts seen throughout our lives.
Enjoy!
Momentum is mass times velocity. It is inertia or mass in motion. A moving object can have a large momentum if it has a large mass, a high speed, or both. In our case, the car. The car had more momentum than the skateboard moving at the same speed because the car has more mass. Whereas the car at rest had no momentum because it had no speed. Despite the fact that the skateboard has less mass, it had more momentum. This is because the skateboard was moving at a larger speed. Impulse equals force times time, a change in momentum. The change in momentum depends upon the force that acts and the length of time it acts. This was seen in our toy car experiment. When we applied a force to the toy car, we produced a change in momentum. It was originally at rest and then moved with greater speed, eventually slamming into the wall. When we applied the same force to the toy car over an extended period of time, there was a greater change in the car's momentum than applying the same force briefly. Force was smaller and time was longer. It didn't slam into the wall as forcefully. Whereas when we applied more force with less time, the force was much greater, and the toy car slammed more forcefully into the wall. As for the car example, when we applied the brakes with great force, the time was smaller and thus the stopping distance was shorter. This was seen as the car jolted forward. Whereas when we applied the brakes with less force, the time was greater and thus the stopping distance was greater. This was seen as the car gradually moved forwards. You see, because the car has more momentum, it's harder to stop. And therefore, we must apply greater force to stop the car, and this is seen, the after result is seen as the car jolted forward. As for the egg example, it clearly demonstrates impulse versus momentum. When we threw the egg against the blanket, it didn't break simply due to impulse. The egg was initially at rest, so when thrown against the blanket, it experienced a change in momentum. The blanket is a soft object and therefore extends the contact time of the egg with the blanket. Extending the contact time, the time during which your momentum is brought to zero and the egg meets the blanket, you decrease the force exerted on the egg. Thus you decrease the resulting deceleration. Whereas when you drop an egg onto a plate, it will break, as seen. This is because you are dropping it onto a harder surface, decreasing the contact time of the egg with the plate and increasing the force. The egg simply can't sustain the greater force imparted by the plate, and thus it breaks. As for our water balloon fight, when we caught the water balloon in midair, we imparted a force to bring its momentum down to zero, therefore stopping it from bursting. We are bringing about a momentum change equal to the original momentum of the object in movement, also showing conservation of momentum. Otherwise, we couldn't simply bring the water balloon to rest. We brought the balloon to a stop slowly by traveling with it a few feet. Impulses are greater when an object bounces. In fact, the impulse required to bring an object to a stop and then to throw it back again is greater than the impulse required merely to bring the object to a stop. This is because there is a great change in momentum, or impulse, as we've noted before, from having the object originally in motion, then bringing it to rest, and having it in motion and accelerating again. The acceleration is much greater. Impulse is also equal to m vf minus vi, or final velocity minus the initial velocity, also known as the change in velocity or acceleration. With enough force, the water balloons will burst easily, getting the water onto you. I hope you enjoyed these experiments, and it clearly demonstrated the concepts that we have proven throughout this video, and that it was entertaining and helped you better understand impulse versus momentum, how similar they are, and how different they are as well. Thank you.